Right now, without thinking about it, you know that the chicken in your fridge has to be cooked. You know the shiny red berry by the trail might kill you. You know the carton in your door says milk, so it is safe to drink. You did not earn a single piece of that knowledge. You were handed all of it for free the day you were born. So let me take it away. All of it. Imagine you wake up as one of your own ancestors a few 100,000 years ago. There are no labels, no expiry dates, no parent who already knows the answer, because nobody knows the answer yet. And here's the part people forget. There is no fire. Not yet. Just you, a body that needs about 2,000 calories before the sun goes down, and an entire living world in front of you that has no idea whether it is your dinner or your funeral. Everything you put in your mouth is a bet, and the house does not play fair. Start with meat. We love to tell the story of early humans. Like meat was the easy win, the protein jackpot. It was not. Raw meat is a minefield. That fresh kill can be loaded with trichinella, a roundworm that hatches in your gut and then burrows out into your muscles, your heart, and your brain. It can carry tapeworms that grow longer than you are tall and quietly starve you while you keep on eating. It can hold salmonella, listeria, campylobacter, none of which you can see or smell or taste. And you cannot cook a bit of it, because the single greatest tool for making meat safe, heat, has not been invented in your world. Every meal is raw. Sit with that for a second. Your ancestors are eating raw flesh every day with no fire, and they are not dying out. That alone should stop you cold. Now look at the animals themselves. You would think the rule is simple. Avoid the things that can hurt you. But the deadliest creatures in this story never lift a finger against you. They just wait to be eaten. The pufferfish carries tetrodotoxin, a poison more lethal than cyanide, with no antidote then and no antidote now. In the forests of New Guinea, there is a small orange and black songbird called the hooded pitui, and its skin and feathers are soaked in beta-cotoxin, the same family of poison as a dart frog, also deadlier than cyanide. A biologist named Jack Dumbacher proved that in the journal Science in 1992, and the local people had known it for generations. They called them rubbish birds, and they would only eat them skinned and specially prepared. Walk to the coast, and it gets worse. A completely normal-looking clam in the wrong week of the year can be packed with saxitoxin from a red tide, one of the most powerful natural poisons on Earth, enough to shut your lungs down in a few hours. And it looks exactly like the safe clam you ate last month. That is the real trap. The danger is invisible. The berry that kills you does not taste like death. The clam that stops your breathing looks like lunch. The mushroom that dissolves your liver, and we will get to that one, actually tastes pleasant. Nature did not mark the exits, and you still had to choose. Out of everything that walks, swims, grows, and crawls, your ancestors had to sort the entire living world into food, and never, with no chemistry, no microscope, nobody to ask, and a death sentence waiting for a wrong guess. Or even better, think about this. At some point, one of your ancestors stood next to another animal, a goat, a sheep, a wild cow, and drank the warm fluid that came out of its body. Milk. Stop and feel how strange that actually is. No other adult mammal on the planet drinks milk, not even its own mother's milk, once it is grown. And here's the twist almost nobody hears. The humans who first did this could not even digest it. They were lactose intolerant. Every last one of them. The ability to drink milk as an adult, called lactase persistence, did not exist yet today. It is the most strongly selected gene in the entire human body over the last 10,000 years, according to a 2022 study in Nature led by Richard Avershede at the University of Bristol. Back then, almost no one carried it, so the first milk drinkers got sick. And instead of quitting, they worked out how to turn raw milk into cheese and yogurt, stripping out the very sugar their guts could not handle. Thousands of years before anyone knew what sugar or bacteria even were. Read that again. They fixed a problem that was written into their own DNA without knowing that DNA or sugar or bacteria existed. Here's the part I really want to land, because nobody says it out loud. We like to picture ourselves, modern people, with our labels and our science as the finished product. And we picture our ancestors as the rough draft, the weaker version, the ones still figuring it out. When it comes to food, that is exactly backwards. Take any of us, strip off the labels, put out the fire, empty every store, and drop us into that world, and most of us would be dead inside a month. They were not. They ran that gauntlet every single day for hundreds of thousands of years, and they won it so completely that you exist to hear this. That may be the strongest evidence we have that in the ways that actually kept a body alive, ancient humans were not the weaker version of us. They were tougher, sharper, and paying far closer attention than almost anyone alive today. So, how did they do it? How do you learn that this root is food, and that identical-looking one is poison, that this fish is a feast, and that one is a corpse, that this meat needs fire, and that milk needs curdling? When a wrong answer does not come with a second chance, to see the whole trick, start with the deadliest teacher in the entire story. Meet the death cap, Amanita phalloides. It looks plain, almost boring, a pale greenish cap on a white stem, the kind of mushroom you would walk straight past. It does not taste bitter or rotten or wrong. People who have survived it say, it tastes good. Half of one cap can kill an adult. It is behind roughly 90% of all fatal mushroom poisonings on Earth. And here is its cruelest trick, the poison. Alpha-amanitin gives you nothing for 6 to 12 hours. No pain, no warning. By the time your stomach turns, the toxin is already deep in your liver, taking it apart cell by cell. Then, often you feel better for a day. That false recovery is the poison finishing the job. It may have killed a Roman emperor, Claudius, in the year 54, and a Holy Roman Emperor, Charles VI, in 1740. And it still kills expert foragers today. Northern California alone saw an outbreak of 14 poisonings in late 2016, with people needing liver transplants, and another wave from late 2025 into 2026, with dozens sickened and several dead. Stop and look at what the death cap really is. It is a food that walks straight past every alarm your body owns. It is not bitter. It does not smell of rot. It does not hurt going down. If your whole defense against poison was your own tongue, the death cap beats you every time. So the lazy answer, the one you have probably heard, is that early humans just used trial and error. Somebody ate it, somebody died, everyone else learned. And sure, that is part of it. But trial and error cannot explain a mushroom that kills you a day later, long after you would ever connect it to your meal. It cannot explain how people learn to eat a root that is naturally full of cyanide, one that now feeds 1 billion people. It cannot explain a 12-step recipe where every step is invisible and skipping any one of them cripples you. Trial and error with a delayed death sentence does not teach a lesson. It just kills the teacher. The real answer is stranger and far more impressive. Ancient humans did not survive on one trick. They survived on 3 survival systems stacked on top of each other. One was already built into the body before they were born. One came from watching the world around them, and one was passed down hand to hand across so many generations that no single person alive even understood how it worked. Put those 3 together, and you get the strangest, most underrated superpower our species has ever had. Let me show you all 3. Start with the one you're using right now without knowing it. Your body came preloaded before an ancient human learned a single thing. Evolution had already installed an alarm system on the tongue. Taste is not there for pleasure. It is a chemistry test you run on every bite, before you swallow, and each flavor is a verdict. Bitter is the poison alarm. You have a family of about 25 working bitter taste receptors coded by genes called TAS2R, and their entire job is to catch the toxic compounds that plants make to avoid being eaten. This system is old, far older than humans. A 2024 study traced the origin of bitter taste receptors all the way back to the common ancestor of jawed vertebrates, including sharks, hundreds of millions of years ago. Think about that. The wince you make biting something bitter is a reflex you share with a shark. Plants fight back with chemistry with alkaloids and cyanide compounds, and bitterness is your inherited warning that a plant is armed. It is why children gag at broccoli and Brussels sprouts. Those plants really are mildly loaded with bitter defensive compounds, and a small child's body, with the most to lose, is screaming the loudest to avoid them. And people are not even wired the same. In 1931, a chemist named Arthur Fox accidentally puffed a compound called PTC into the air and discovered that some people taste it as intensely, disgustingly bitter, while others taste nothing at all. About 3/4 of people are tasters, a quarter are not, and we share the very same split with chimpanzees. That is not random. A population where some members are hyper alert to bitterness and others are willing to eat a wider menu is a population that hedges its bets against both poison and starvation. Now, flip it around because your tongue does not only warn you, it also says yes. Sweet means safe energy, ripe fruit, quick calories. So your brain rewards it hard. Umami, the savory taste identified by the Japanese chemist Kikune Ikeda in 1908, is the flavor of glutamate, which means protein, which means meat and growth. Salt means the minerals your nerves and blood need to run. Sour flags acid, unripe fruit, or the early edge of spoiling. Line them up, and your tongue is a dashboard your ancestors read at every meal. Bitter? Careful? Sour? Not yet? Sweet? Yes. Umami? Yes. Salt? Yes, a full chemical readout of your food running before you even decide to swallow. But taste is only the first gate because plenty of danger has no flavor at all. So the body layers on a second sense, disgust. That full body recoil you feel at rotten meat, at maggots, at the smell of decay is not squeamishness. The scientist Valerie Curtis at the London School of Hygiene and Tropical Medicine spent her career arguing that disgust is a behavioral immune system, a set of feelings evolved to keep you away from infection and poison before they ever get inside you. Rotten smell, slimy texture, the sight of decay. These are the fingerprints of food that will hurt you, and disgust yanks you back without a single conscious thought. Paul Rosen at the University of Pennsylvania called this the omnivore's dilemma. An animal that eats everything must be curious enough to try new food, but cautious enough not to be killed by it. And disgust is the brake that balances the gas. And then there is the single most elegant trick your body has, and you have almost certainly felt it. Think of a food that once made you violently sick. You probably cannot even picture it now without your stomach tightening, even if it was years ago. Even if you know for a fact it was a stomach bug and not the food at all. That is not a quirk. It is one of the fastest and most powerful forms of learning in all of biology. And it has a name, conditioned taste aversion. A psychologist named John Garcia proved it in the 1950s and 60s. He gave rats a new flavor, then hours later made them nauseous, and the rats refused that flavor forever after a single try. That broke the rules of learning at the time. Everyone believed cause and effect had to be nearly instant to connect. Garcia showed that when it comes to food and sickness, and only food and sickness, the brain will reach back across hours to pin the blame. Your ancestor eats an unfamiliar plant at dawn, gets sick by noon, and never touches it again for the rest of their life. One trial, no teacher. That is your body writing its own poison list. And it protects you before you are even born. Morning sickness looks like a cruel design flaw, making a pregnant woman miserable exactly when she needs to eat. But biologists Margie Profit and later Samuel Flaxman and Paul Sherman at Cornell showed it is a shield. Flaxman and Sherman gathered data across many cultures and published it around the year 2000, and the pattern was unmistakable. Nausea peaks in the first trimester, exactly when the embryo is building its organs and is most vulnerable to toxins. And the foods that trigger it most are the ones most likely in the ancient world to carry poisons or dangerous microbes. Strong-tasting vegetables and meat. The body is fencing off the risky menu at the one moment a small dose could do the most damage. There is even a version of this in toddlers. Around the age they start walking and can suddenly reach food on their own. Many children slam shut and refuse anything new. Parents call it picky eating. Biologists call it food neophobia. And the timing is not an accident. It is a safety switch that flips on at the exact moment a small human gains the freedom to put the wrong thing in its mouth. So add up System 1, a tongue that runs a chemistry test, a gut that recoils from rot, a brain that can learn a poison in a single sickening afternoon, a pregnancy that raises its shields on schedule, a toddler that defaults to no. Your ancestors walked into the world already carrying millions of years of hard-won answers, written into the body itself, but the body only gets you so far. Because the death cap, remember, sails straight past all of it. For the truly hidden dangers, they needed a second system. They watched. Here's a thing you might never have considered. If you want to know what is safe to eat in a strange place, you do not have to test it on yourself. You can let something else test it first. And animals, it turns out, are constantly running those tests. They self-medicate. There's a whole field for this now, called zoopharmacognosy, and a landmark review in the journal PNAS in 2014 laid out how widely animals dose themselves with the natural world. Chimpanzees swallow rough leaves whole to scrape parasites out of their guts. Sick animals seek out specific plants they otherwise ignore. And this is not new knowledge. Aristotle and Pliny the Elder, thousands of years ago, wrote down stories of animals healing themselves and of humans copying them. And copy them we did, in ways that are honestly genius. Go high into the Andes. Wild potatoes grew there, but many of them are bitter and toxic, full of the same defensive compounds, glycoalkaloids, that make the green parts of a potato dangerous today. So how do you eat a poisonous potato? The people there watched the animals. Guanacos and vicuñas, the wild relatives of the llama, were seen licking clay before eating certain harsh plants. Wild parrots and macaws in the Amazon do the same thing, gathering at exposed riverbank clay licks to eat mouthfuls of dirt. It looks bizarre until you understand the chemistry. The clay binds to the toxins, grabbing them like a sponge so they pass through the body instead of poisoning it. And the Andean people worked out the same move. They would dip their bitter wild potatoes in a slurry of clay and water and eat the poison safely, coated. A scientist named Timothy Johns at McGill University later tested this in a lab and confirmed it. The clay really does bind those potato toxins right there in the test tube. People had been running a chemistry experiment on a mountainside for centuries and getting the answer right long before there was a lab to prove it. But watching animals and testing on your tongue together still cannot get you all the way, because the hardest foods of all cannot be solved by one person in one lifetime, no matter how clever or how careful. For those humans needed the third system. And this is the one that makes us truly strange. We inherit knowledge we do not understand. Let me give you the single best example on Earth. Cassava, also called manioc or yucca. If you have ever eaten tapioca, you have eaten cassava. It is a root crop that feeds around 1 billion people today, and it was domesticated in the southern Amazon roughly 10,000 years ago. There is only one problem. Many varieties of cassava are laced with cyanide. A compound in the root, linamarin, releases cyanide when the plant is damaged, which is exactly the plant's defense against being eaten. Eat bitter cassava raw or process it wrong, and it can paralyze or kill you. So how do you turn a cyanide factory into a staple food? The Tucanoan people of the Northwest Amazon have a way, and it is long. They grate the root, then press it, then wash it, then let it sit, then cook it, a multi-step sequence that stretches over days and pulls the cyanide out. And here's the detail that changes how you see our whole species. When the anthropologist Joseph Henrich, now at Harvard, studied this, he found that the people doing it could not tell you why each step mattered. They did not talk about cyanide. They could not explain the chemistry. They did it because that is how it is done, because that is what their mother did, and her mother before her. Skip a step and nothing bad happens today or tomorrow. The cyanide from underprocessed cassava builds up slowly and can cause a permanent paralysis of the legs, a condition called konzo, or other harm too slow and too delayed to ever trace back to a shortcut in the kitchen. That is the whole secret right there. Henrich calls this the secret of our success. No individual invented the cassava process. No individual even understands it. It was assembled across countless generations. Tiny accidental improvement by tiny accidental improvement, and passed down as sacred, unquestioned ritual. The knowledge is smarter than any single person who carries it. It is a kind of intelligence that does not live in a brain at all. It lives in the culture, in the handing down. And once you see that pattern, you see it everywhere. Go to California, where dozens of tribes lived on acorns. Acorns are full of tannins, bitter and hard on the body in quantity. So the people developed a process: shell them, grind them into meal, and then leach them, pouring water through the meal again and again, for hours to rinse the bitterness away before cooking. Nobody was measuring tannin content. They inherited the method, and the method worked. Go to Mesoamerica and watch people make maize edible in a way that would save millions of lives without anyone knowing the mechanism. They soaked their corn in water mixed with wood ash or lime, a process the Aztecs called nixtamali, which we now call nixtamalization. This does something invisible and profound. Corn contains niacin, vitamin B3, but in a form your body cannot absorb. The alkaline soak unlocks it. Skip that step, and a diet heavy in corn leads to pellagra, a brutal disease of the skin, the gut, and the mind that can end in death. And here's the proof that the step itself was the hidden knowledge. When maize was carried out of the Americas to Europe and the American South, people took the crop, but they left the ash and lime behind, because who would think the ash mattered? And pellagra exploded into epidemics, killing and maddening hundreds of thousands of people for centuries. The corn crossed the ocean. The wisdom did not. The recipe was the science. So how does knowledge this fragile survive at all, generation after generation, when one drop step means disease? Two ways. First, people learn it absurdly young. A study in PNAS in 2024, looking at hunter-gatherer groups in the Congo Basin, found that children know a huge share of the safe and dangerous plants around them by the age of 6 or 7, learned not from one teacher, but from the entire community, by watching and copying and doing. Second, cultures wrap the knowledge in something stronger than memory. In taboos, in stories, in rules you obey without questioning. Precisely so that a curious teenager does not have to rediscover the poison the hard way. A food taboo that says never eat this or always prepare that this way is often a database of survival, encrypted as a rule. And sitting quietly behind all three systems is the one invention that changed the menu forever: fire, cooking. The Harvard biologist Richard Wrangham argues that controlling fire did not just make food tastier, it made food safe, and it made us human. Heat kills the parasites in raw meat. It breaks down toxins. It unlocks calories our guts could never have pulled from raw plants. Wrangham's case is that cooking let our ancestors grow bigger brains and smaller guts, that we are, in a real sense, the animal that cooks, and it detoxifies on demand. Take the ordinary red kidney bean, raw. It contains a toxin called phytohemagglutinin, and eating just a handful uncooked will make you violently ill. Boil them for 10 minutes, and they are perfectly safe. The bean is both poison and dinner. The only difference is fire, and the knowledge of how to use it. So now you can see the full picture. A body that came preloaded with alarms, eyes that watched the animals and copied their tricks, and a river of inherited knowledge, learned in childhood, locked inside ritual and taboo, and finished with fire, carrying answers no living person could have worked out alone. Three systems stacked. That is how you survive a world with no labels. And the best proof that this is really how it worked is what happens when the chain breaks. Go to Australia, 1861. The explorers Robert Burke and William Wills are starving in the outback, and around them grows a fern called nardoo, which the local Aboriginal people ate safely for generations. Burke and Wills gathered it and ground it into flour and ate it, and they kept getting weaker, even as they ate more. What they did not know is that the Aboriginal people did not just grind nardoo. They roasted it and prepared it carefully, because raw nardoo is loaded with an enzyme called thiaminase, which destroys vitamin B1 in the body. Burke and Wills were eating themselves to death, starving, while their bellies were full because they took the food but skipped the knowledge. Wills wrote in his diary, with terrible calm, that starvation on nardoo was by no means very unpleasant. They both died. The plant was safe. The missing step was fatal. And this is not just history. Konzo, the cassava paralysis, still strikes during droughts and wars when frightened, hungry people rush the processing to eat sooner, and the cyanide is not fully washed out. The death cap still kills experienced foragers every single year, because no inherited rule can cover a poison that tastes good and waits 12 hours to strike. When the knowledge holds, we eat like kings. When it drops a step, people die. That is how you know the knowledge was doing the work all along. So how did ancient humans figure out what was safe to eat? Not with one brave taster, not with luck. They did it with a body that had been learning for hundreds of millions of years before they were born. They did it by watching every other creature and stealing its answers. And they did it by building a tower of knowledge, one careful hand passing to the next across 10,000 years until it held wisdom that no single mind inside it could ever have contained. Here is where it comes all the way back to you. Every time you eat tapioca, someone worked out how to strip cyanide from a root. Every time you eat an almond or a kidney bean chili or a corn tortilla, you're trusting a chain of people, most of them dead for thousands of years, who paid in sickness and in lives to learn what you now do without a thought. You did not have to guess. You did not have to bleed for it. The death cap warning still reaches you across all that time because someone remembered and told someone, who told you. So the next time you open the fridge and you just know what is safe, remember what that knowing really is. It is the oldest inheritance you own. It is the single longest running experiment in human history. And you are the proof that it worked.